All right, everybody. Hello and welcome. My name is Andy Kuszak. I am a home inspector in Arkansas. I've been a home inspector for about 10 years. And then before that, I was in commercial construction. And before that, I was in residential construction. And through all of those experiences, I've always had a heart for education and advanced education and just as much education as I can get. And so I ended up working with InterNACHI and became a education partner. And so here we are. So just keep in mind that the class content was pre-approved by your state, and so we have to follow the class content. We're going to have about 10 minutes at the end of every hour, and then at the very end of the class to answer your questions. So let me get through the content and save your questions. And then we'll get to them. And if we can't get to them within the 3 hours, which we should have plenty of time to do that, or if I don't know the answer, please email me and I will get you the answer. My email is andy@asuperiorinspection.net. And like I said, if I can't answer it, we'll find somebody who can, or I'll get you to the InterNACHI group that can answer that for you. So the class we're doing today, 25 standards every inspector should know. There's a lot of inspectors, everybody, a lot of standards that everybody should know, but these 25 are a good starting point. So here we go. Let's see. There we go. And let me move my windows around here so I'm not okay. All right. Inspecting a residential building involves looking at many interrelated elements. Inspectors must examine mechanical systems such as the dwelling's plumbing and electrical, as well as structural components such as the roof and the garage, and several more features in between. This manual provides the fundamentals for inspectors to recognize defects and potential hazards, as well as the proper installation and operation of the most common systems and components in a home. The inspector can then confidently pass on useful information to the homeowner. As always, we got to know that we are not code inspectors, but we use code every day in our job. So just keep that in mind. Cool. All right, and let me move my windows around here so it's easier for me to see stuff. 1 second. Gotta make my. Okay. All right, so we're going to follow the numbers around as we go. And so we're going to start with number 1. So service. Service is a general term used to refer to all of the service conductors and equipment for delivering electricity from the utility company to the wiring system of the building served. The service begins at the load end of the service drop or lateral and ends at the enclosure that houses the main disconnecting means. It is typically referred to as the main panel. The first point of disconnect for the conductors from the utility company is the service or the main panel. Number 2, over here on the right. Only one service should be installed for each dwelling or building. A minimum 100 amp service is needed for a single residential dwelling unit. Number 3, the service panel is not allowed to be located inside a bathroom, over stairs, or inside a clothes closet. Just keep in mind that homes were built before electrical code standards, and so you will often find electrical panels in places that today would not be recommended. So number 4, refer to the following table when inspecting the service or feeder cable. So over here on the left-hand side, you're looking at 100 amp rating, 100 amp service rating. So you should have a minimum of number 2 aluminum and number 4 copper. And then as we go down the list here, 125 goes to 1-aught or number 2, 150 amp goes to 2-aught or number 1, and 200 amp service goes to 4-aught or 2-aught for copper. And then on to number 5 over here on the top right-hand corner. Service entrance conductors must be protected from abrasion by the use of plastic bushings. Bonding bushings and jumpers are required to be used for metal conduits entering the panel enclosure through concentric or eccentric knockouts. It is often that you will find, especially on remodels, where you're missing a lot of those bushings or those connectors in the top of those panels. So keep an eye out for those. Number 6, here in the middle, a means of disconnect for the service must be located either outside or inside the dwelling unit near the point of entrance of the service conductors. No more than 6 hand movements or no more than 6 circuit breakers may be used to disconnect all service. Typically, a main disconnect switch is required by the local authority. The main disconnect should be clearly marked to identify that it has the service disconnect. Scroll up here. Number 7, which is down here at the bottom. A grounded conductor is a conductor that is grounded. The grounded conductor is commonly referred to as the neutral conductor. It is usually identified by white or gray insulation. Number 8, an ungrounded conductor is a conductor that is not grounded. The ungrounded conductor is commonly referred to as the hot or line conductor. It is usually identified by black or red insulation, any color other than green, white, or gray. Then we're going to number 9, which is down here in the bottom, which is actually blocked by my Zoom stuff. But number 9, a grounding electrode is a device that makes an electrical connection to the earth. A grounding electrode can be rebar in a footer, copper underground water pipe within 10 feet of contact with the earth, or a grounding rod. Number 10, which is over here on the far right, an equipment grounding conductor is used to ground the electrical equipment. The equipment grounding conductor is commonly referred to as the ground. These conductors are typically identified by green insulation or the conductor is bare. And then over here on the bottom right of this middle picture, a grounding electrode conductor, which is commonly referred to as the GEC, is a conductor used to connect the grounding electrode to the equipment grounding conductor, the grounded conductor, or both at the service, at each building or structure that is supplied by a feeder or branch circuit, or at the source of a separately derived system. The GEC, grounding electrode conductor, is a conductor used for grounding at the service or separate building. The GEC is used to connect the grounding electrode system. Number 12, down over here. The main bonding jumper must be installed to connect the grounds in the neutral bars and make connections to the enclosure. Number 13, all unused holes in the panels should be closed. Number 14, right over here, white insulation conductors that are used as ungrounded conductors or HOTS should be identified at all termination points, meaning a lot of times you'll see black tape wrapped around a white conductor. And let's see, where we're at, 14, 15, all 15 and 20 amp 120 volt circuits for dining rooms, living rooms, bedrooms, sunrooms, closets, hallways, or similar areas must be AFCI protected. So keep in mind, guys, when we're talking, or keep in mind, folks, that we have a lot of our standards are new standards. So homes that are existing or older, or code was not implemented at the time that the house was built, you're going to find a variation of configurations and installation methods. So when you're going through a home, just make sure that the home is safe. I guess that's our primary job as home inspectors, to make sure our homeowners, home buyers, are going to have a safe home. So, and then lastly, number 16 at the top left of the, well, in the middle picture here, each cable should be secured to the panel board enclosure using listed cable connectors. Again, on remodels and flips, any experienced home inspectors will know that you can find all kinds of different materials inside of electrical panels by flippers who unfortunately don't know any better. All right. And okay, standard number 1, electrical panels. So remember, sheet metal screws are not allowed for grounding connections. Again, kind of one of those flipper deals. You got to keep an eye out to make sure that the proper components are installed on the at the correct locations. Unused openings for circuit breakers should be closed. With approved panel covers or inserts. Correct breaker type should be used for each panel board according to the manufacturer's label. And each circuit should be clearly and specifically identified as to its purpose. No two circuits should be labeled the same. No circuit should be identified in a way that may be subject to the change, with occupancy. For example, no breaker should be labeled Ben's room. And then we have this awesome little picture over here. So you should be able to find this or something like this on a lot of panels where it says, warning, use only with GE type breakers. Use of other circuit breakers voids the warranty, may void the UL listing, and could result in property loss or personal injury. The circuit breakers in this box have been selected to protect the wiring. To avoid damage and loss of protection, do not replace with higher amperage rated breakers. If changes are necessary, call a qualified electrical contractor. And then two terms that you should keep in mind when evaluating the electrical system. An outlet is a point on the electrical wiring system where electrical current is taken to supply equipment. An outlet can be a wall receptacle, a light fixture, a smoke detector, or an appliance. A wall switch is not considered an outlet since no current is taken at the switch. Current is simply passing through. And then the second term to keep an eye on is a device. A device is part of the electrical system that is intended as its primary function to carry or control electricity but not use electricity, such as a switch or a thermostat. So just real quick, again, with flippers or homes that are existing or have been around for a while, a lot of times you are going to find different manufacturers' breakers inside of a panel. So there is a lot of controversy with that statement. You'll find if you call something out like that, you'll have one electrician who will agree with you and say, yep, we need to replace all these breakers. And then the next electrician that comes out is going to throw you under the bus and say, no, it's totally fine. There's nothing wrong with it. They're all UL listed. So definitely we are always on the side of the homeowner and doing what is the safest and the most proper process and installation. So calling out for mismatched breakers, you gotta, it's our job. Now I will say there are manufacturers that own multiple different brands, and so a lot of times those brands can work in the different branded panels. But to know what those are, you got to do your research and look them up. So if you're going to call out something like mismatch breakers, make sure you do your due diligence and go in there and make sure that the manufacturer of those breakers are not actually the same company. On to next, electrical subpanels. Let's see. Each grounded conductor or neutral wire shall terminate on an individual terminal that is not also used for another conductor, except where the terminal is identified for connection of more than one conductor. Multiple grounding conductors or grounding wires may be installed under the same terminal if they are the same size, and the maximum number of conductors does not exceed the recommendations of the panel manufacturer. In addition, subpanels should be supplied with 4 conductors to isolate grounds and neutrals. The SER, which is the service entrance cables, are commonly used to supply electricity to subpanels. A typical subpanel is commonly supplied by a 100 amp feeder using number 2 aluminum or a number 4 copper cable. Number 3, the equipment grounding bar must be bonded to the subpanel enclosure, and a bonding jumper to the neutral bar must not be installed. And then 5, lastly, a main breaker is not required for the subpanel if overcurrent protection is provided for the feeder conductors. So again, back to older or homes that really didn't have a code implementation in your area, you're going to find a lot of neutrals Many times, 3, sometimes 4, if you have a really dedicated electrician who are going to, multi-tap the neutral bus bar there. In my reports, this is just what I do. I'm not recommending that you do this. I'm just telling you from my perspective. I put in my reports is that multiple conductors underneath a single lug is not recommended due to continuity issues. Recommend a licensed electrician. Methods may have been common like this in this area, but nevertheless should be evaluated by a licensed electrician. And I kind of butchered that a little bit, so I apologize. But I think hopefully you get the concept I was going for. And again, on the ground wires, you can have multiple wires underneath the lug as long as they're the same size one. All right. All right. Standard 3, roofing underlayment. I'm gonna read this and then I'll give you a bunch of stories on this one. In areas where there is a history of ice forming along the eaves, causing a backup of water, an ice barrier that consists of at least 2 layers of underlayment cemented together, or a self-adhering polymer-modified bitumen sheet shall be used in lieu of normal underlayment and extend from the lowest edges of all roof surfaces to a point at least 24 inches inside the exterior wall line of the building. Detached structures without conditioned areas are the exception. All underlayment shall be layered under the rake flashing and over the drip edge flashing. This configuration sheds water away from the roof structure instead of trapping it. So so 10 years in the business, I have, since I started in the business, I have always called out the orientation of underlayment being under the drip edge at the fascia end of roofs. And over the last 10 years, it's probably gone from 90%, 95% of the time seeing it incorrect to about 85% of the time seeing it incorrect. And so usually what I tell clients when I see this, and so when I call this out in my reports, I always kind of give a precursor to the client and to the homeowner, because most of the time, I would say 90% of the time, the builder is not going to fix this. They're going to say, this is how we do it. This just the way it is. You're just going to have to deal with it. And so because my clients have gotten that response so many times, while I still call this out as being incorrect, I do kind of tell them with this precursor that, hey, while this is not right, more than likely you will not have a problem with it for the next 10 years until the shingle starts to degrade, or if there is a storm where maybe they have a tree branch go through and then they have water getting underneath the shingles. I just let them know that, in my area, we have a lot of hail. We have a lot of hail damage. And so I tell them, by the time the next hailstorm comes through, you more than likely won't have any issues associated with the underlayment not being configured correctly. So just when you get a new roof, make sure your roofer does it correctly. So the issue here is that when water gets underneath the shingles and it rides that underlayment all the way down to the drip edge, instead of it rolling off the underlayment and going into the gutter or going off of the roof, off of the drip edge, then it can get trapped between the drip. So say my hand is the drip edge, and instead of water going over the top and coming down, it's going to go under that drip edge, and then it gets trapped at the edge of that, at the end of the sheeting. And then over time, especially, if it's ongoing, then that the roof decking is going to rot from the fascia up. So when I go into an attic and I'm inspecting the attic spaces, I try my hardest to look all the way down until you see the fascia board and the roof decking meet at that joint. And if they have any or had any issues in the past, you'll start to see the roof decking is starting to get black or really dark. You start to see water staining, and the worse it gets, the more it travels up that roof decking. So again, a lot of times you don't see that until the houses have started to age or the roof has started to age 10, 15, 20 years. Or if the gutters, for whatever reason, if the gutters have been damaged over time and they, instead of the water going into the gutter, maybe they have gutter screens and then all the tree debris gets on top of that gutter screen. Well, then water hits that tree debris, doesn't go into the gutter. And that tree debris, it actually causes a little dam there. So the water hits that dam and then it starts to flow back into the shingles. And then once it flows back up under the shingles and then it gets down underneath that drip edge. And then again, you start to rot that roof decking from the edge up. So definitely pay attention to that in existing homes, older homes or older roofs, and do your best to try and look all the way around the perimeter of the house and see if you can find some damage going on. Standard 4, glazing. Many areas are hazardous because of their frequent impact by buildings' occupants. Glazing located indoors is a particular concern because of the increased probability of accidental impact while operating the doors. A person may often push against the glazed portion of a door in order to operate it. A large piece of glass located along a travel path where no barrier is provided is a dangerous area. And then, let's see. Glazing is, so the definition of glazing. Glazing is glass or other transparent or translucent glazing material. The glazing area is the interior surface area of all glazed fenestration, including the sash, curb, and framing elements. For example, in the 2018 IRC, which is the International Residential Code, R303.1 says that habitable rooms must have an aggregate glazing area of not less than 8% of the floor area. Fenestration refers to windows, vertical fenestration, skylights, and sloped glazing. Fenestration includes products with glass or other transparent or translucent glazing material. And then vertical fenestration refers to windows that are fixed or movable, opaque doors, glazed block, and a combination opaque and glazed doors installed in a wall at less than 15 degrees from the vertical. For example, a double hung window is a vertical fenestration. And then sloped glazing refers to glass or other transparent or translucent glazing material installed at a slope of 15 degrees or more from vertical. For example, a skylight is a factory assembled sloped glazed fenestration unit that has one panel of glazing. In general, each pane of glazing located in specific hazardous locations defined in the 2018 IRC section 308 must be of the safety glazing type. The safety glazing must have a manufacturer's designation or label that is visible and permanent and which identifies the type of glass and the safety glazing standard with which it complies. For the purpose of glazing, the following areas are considered specific hazardous location. Glazing in swinging doors, except, and I'm going to butcher this, but jaloises, like, glazing in fixed and sliding doors, glazing in sliding and bifold closet doors, glazing in storm doors, glazing in all unframed swinging doors, glazing in doors and enclosures for hot tubs, whirlpools, saunas, steam rooms, bathtubs, and showers, and glazing in any part of a building wall enclosing these compartments where the bottom exposed edge of the glazing is less than 60 inches measured vertically above any standing or walking surface. Be particularly careful in checking windows inside bath and shower assemblies. Number 7, glazing in an individual fixed or operable panel adjacent to a door where the nearest vertical edge is within 24-inch arc of the door in a closed position and whose bottom edge is less than 60 inches above the floor or walking surface. All right, just a quick example so we can take a little break with reading these definitions. I did a new construction, I think it was a $650,000 house, 2 stories, super nice. And they still were missing a lot of glazing or a lot of safety glazing in windows. So I specifically called out on the back patio, the door swung open into a single hung double pane window that was not safety glazed. So called that out, and builder definitely, he came back, said, yeah, we definitely missed that. And so what you're going to find in new construction when you're looking for these things is, say for instance, a window broke during installation, or on the truck as it was being brought in. And so then they go and they take a window from another build, and then they put that in, and nobody remembers to buy a window for the house that it was pulled from. And so then they just put in a normal window, and a lot of times they're like, we'll just, whether they're intentional about it or not, it's wrong. So just keep an eye out. Even though the house is brand new, even though things are brand new, does not mean that shortcuts were not taken, or something happened in the whole process of construction that caused them to shift and change something, and then it kind of gets forgotten about over time. So, all right, back to definitions. Let's see. I'm sorry, I got the sun is beaming in on me. Um, all right, so glazing in a panel, other than those locations described previously, uh, that meets all of the following conditions. So, let's see. 8.1, exposed area of an individual pane larger than 9 square feet. The bottom edge is less than 18 inches from the ground. Top edge is more than 36 inches above the floor, and one or more walking surfaces within 36 inches horizontally of the glazing, and then all glazing in the railings. So if you have glass panels going upstairs, those all need to be safety glazed. Sunrooms are a huge factor in safety glazing, especially on older homes. So you have an older home that has, the single pane, aluminum frame windows. Those are not generally, there might be some out there that are safety glazed, but I don't think I've come across one yet. So you see, a sunroom, especially when those windows go from floor to ceiling, uh, you know, if there's no protection, they're single pane. Look for the etching in the corners of the windows, and look for that tempered stamp in there where it says tempered, or TMP, or TEMP. Lots of manufacturers have different ways of identifying tempered glass. So, um, and then glazing in walls around swimming pools, hot tubs, and spas where the bottom edge of the glazing is less than 60 inches above a walking surface and within 60 inches horizontally of the water's edge. You definitely don't want to have glass in your pool. That would be a terrible, terrible situation. Um, Glazing next to stairways, landings, or ramps within 36 inches horizontal, uh, within 36 horizontal inches of a walking surface if the exposed surface of the glass is less than 60 inches above the adjacent walking surface. And then glazing next to stairways within 60 horizontal inches of the bottom tread of any direction of the exposed, in any direction if the exposed surface of the glass is less than 60 inches above the nose of the tread. So where you'll see this a lot is in older homes, when you have a stairway with a midway landing, and that landing is on the exterior of the perimeter wall, and you have a window at that landing. Very, very common to have, those windows to not have safety glazing. So, someone loses their footing, loses their step when they're walking down the first flight of stairs, and they slide into that landing, and maybe their feet catch, and so then they tumble forward into the window, and then they could potentially have a lot of um, get hurt from pushing their hand through the window, their head going through the window, or whatever. And then, so just keep this in mind also, when it comes to safety glazing, it does not apply to glass block. So glass block is considered masonry. So it does not have to have safety glazing. And then there are products and applications that are exempt from requirements for hazardous locations, including small openings and doors through which a 3-inch diameter sphere cannot pass, and specific decorative pieces such as leaded glass. All right. And where are we at? What side? That's 20. Okay. Gosh, we're just 30 minutes in. We're blazing through. All right. Next, garage firewall. So this is something I'm also constantly fighting new construction builders on. And you'll see I have some examples of this at the very end with some personal pictures that I've taken as far as garage firewall inconsistencies. So but we'll go through this. So number one here, start here. The door between an attached garage and a dwelling unit should be a solid wood door, not less than 1 3/8 inches thick. A solid or honeycomb core steel door, not less than 1 3/8 inches thick, or a 20-minute fire rated door. If you're looking for these standards, a lot of times you should find it on the edges of the door, top, bottom, or top, or more than likely it's going to be on the sides. Usually a lot of times on the jam side. But sometimes it gets removed or it gets painted over or whatever. The big thing is, again, in older homes, most of the time, a house built before, probably before 1990, a lot of times you're going to find a hollow core door that goes from the garage to the house, or a house that used to be a carport, or the garage. The garage used to be a carport and it was converted. Sometimes you'll find incompatible doors through those locations, that type of stuff. Although, so number two, although drywall or other approved material can provide a firewall separation at the walls and ceilings between the garage and the dwelling unit, openings that penetrate the separation should be appropriately protected. Again, I'm going to go over some examples here in a second. And then number three, the type of door construction or the fire rating of the door is important. In many jurisdictions, a self-closing device on the door may be required. The entire door assembly may have to be fire rated. In my area, I'm in Arkansas. They are not enforcing the self-closing latches yet. I think it is coming. We have some builders that do, some that don't, but it is currently not required in my area. So some of the big builders, D.R. Horton, they're putting them in because they use a plan that goes nationwide. And so they just buy materials and they ship them all the way around. And so like all of our D.R. Horton houses have self-closing doors, but the Roush Colemans, if you're familiar with Roush Coleman, or there's another one, I can't remember who they are, but like I said, so sometimes you'll see it, sometimes you won't. For me, I don't identify it that it's installed, but when it's not installed, I recommend it to be installed because again, our job is not code inspectors, but we want to provide the most safety for our clients. So I would recommend it, but most of the time the builder is going to come back and say, "No, I'm not going to do that because it's not required." All right. Number four. So where an air duct passes through the drywall, located on the garage side of the firewall separation, the duct material should be a minimum of number 26 gauge sheet material. There should not be any openings in the ductwork within the garage area. So this is kind of a little deceiving. So if a lot of times you're going to have ductwork that will pass through the garage, and that is okay. But having an opening like the register that we see in number 4 is not acceptable. So anything that if you have heating and cooling in a garage, it has to be self-contained within the garage itself. It cannot pass from the garage to the attic or from the garage to the house. Let's see, number 5. We are. Oh, and my picture might have gotten cut off here. So without exception, all electrical receptacles in the garages must be GFCI protected. Number 6, a direct opening between an attached garage and a sleeping room is not permitted. That opening is hazardous. And sorry, my notes here is just talking about the garage door being self-closing is varies by AHJ. So just whatever is appropriate for your location, make those recommendations. All right. So again, you're going to see at the end of this presentation a couple of pictures I took. But what I often come across in new construction is where, let's say, okay, so let's say this back wall right here is the living side of the house, and in this corner right here, they put a water heater. So a lot of times they will install the landing for the water heater before they drywall. And so what they would do is they would box in the landing for the water heater, and then they bring the drywall all the way down to that landing. But then that landing, they don't seal the gap between the drywall and the landing, and they leave that gap opening. So that is technically a penetration in the firewall rating. So you'll see that. I see that all the time on new construction. You'll also see the plumbing penetrations going through the wall on the occupied side of the garage, where they're not, they just blew a hole out through the wall, and they didn't drywall and mud up next to it, or there's no metal ring that's protecting or surrounding it. Let's see, what else do we see here? Or say they put a closet for the water heater in this corner, uh, and then they don't seal, the drywall is not mudded or taped in that closet, and but the door is not weather sealed, so they don't have a weather strip. It's not air sealed. There's no um, combustion venting in there. And so again, even though they put a closet in there and they tried to make the water heater look nice in the garage, they are still required to mud and tape the seams and the screw and nail hole penetrations. So I did a lot of investigation on this, trying to figure out, what was going on and why this was so common. And I think it's a misconception or a misunderstanding of what the fire rating means. So the purpose of the fire rating on the drywall is the thickness of the drywall. And so we know that the drywall tapers on the ends so that the seams can be mudded and taped, so you have a flat wall. So because they taper at the ends, when you have a garage, the garage has to maintain that thickness, that the drywall thickness all the way around. So the screws, the nail heads, if they're countersunk, all those things, they have to be mudded and taped to maintain the thickness of the drywall, which is what the fire rating is meant to do. So just a little piece of knowledge there, that is the purpose behind mudding and taping garage walls, is to maintain that thickness. All right. More on the garage drywall. So it is common for a fire to start in an attached garage. The fire may grow unnoticed by occupants and become a significant hazard. Therefore, a minimum amount of fire protection is needed. This standard requires a minimum level of fire protection from the garage to the dwelling unit. It allows the occupants time to escape in case of a fire. The separation also restricts the spread of fire from the garage to the dwelling unit until the fire can be controlled and extinguished. There should be at least half-inch drywall applied to the garage side to separate the garage from the residence and its attic space. Garages located below a habitable room shall be separated by at least 5/8 inch type X drywall or equivalent. So this is a picture of the separation between the garage and the house, where the sheathing went all the way up to the roof decking to help maintain that fire rating. And can't really see, but ideally, if these are joints, they should be mudded and taped or somehow sealed. Same thing, and again, we just have your standard mudded and taped drywall ceiling. And then this diagram over here just shows that you just, whenever you're evaluating a garage and the separation between the garage and the house, or the garage and the attic, you just want to make sure that, the penetrations, the penetrations from the garage door, the mounting hardware. A lot of times we'll see where maybe the builder on new construction, I see this too, where the builder their scheduling got off. And so the garage door guy comes in before the drywall is put up. And so he mounts his brackets, and then the drywall guy comes in and then installs the drywall up to the brackets. Technically, that is a break in the firewall rating. So we call that out all the time. Now, a lot of times the builder, when they come back and they fix it, they just take a ton of mud and they just patch that hole up. And as long as you identify that to the homeowner, you tell them this is what it was, this is how they fixed it. I would recommend dealing with however you want. But my recommendation, from if it were my house, that they were to install the drywall all the way up to the bracket, and completely encase the bracket, and not just up to the edges. So we see that all the time. Or they run the electrical and they just blow a hole through the ceiling and then run the wires through the ceiling. Any penetration through that ceiling has to be sealed up appropriately with appropriate materials, appropriate installation processes to make sure that that fire rating is maintained. And where so we got 10 more minutes and then we'll take a break. All right, emergency egress. Basements in every sleeping room should have at least one operable emergency escape and rescue opening that opens directly into a public street, public alley, or yard or court. Where basements have one or more sleeping rooms, an emergency egress and rescue opening should be installed for each sleeping room, but is not required in adjoining areas of the basement. Because many deaths and injuries are caused by occupants being asleep at the time of fire, the standard requires that basements and all sleeping rooms have doors or windows that can be used for rescue or escape in an emergency. During a fire, the normal means of escape will most likely be blocked. The sill height of the emergency escape and rescue opening should not be more than 44 inches above the floor. If the emergency escape and rescue opening has a sill height below ground level, a window well should be provided. The window well should have a horizontal area of at least 9 square feet with a minimum horizontal projection and width of 36 inches, with the exception of a ladder encroachment into the required dimension. If an emergency escape window is located under a porch or deck, the porch or deck should allow the window to be fully opened, and the escape path should be at least 3 feet in height. Again, these diagrams are fantastic. They explain exactly what I just read. So just keep this all in mind whenever you're evaluating for emergency egress in basement or walkout basements or in-ground basements. Whatever. We have an older community, retirement community that's kind of up in the hills where we're at. And we have a lot of walkout basements in those areas. And most of them were built in, before 1980. And so there's a lot of homes that do not have proper emergency egress in our area. So this is something that we call out pretty often. So keep that in mind. And one more slide, and then I'll take questions if anybody has any. So drainage, standard 8. So proper drainage of the building site is important in preventing wet basements, damp crawl spaces, erosion, and possible failure of the foundation. Proper drainage should include adequate slope of the ground directed toward drainage devices that are capable of carrying surface water runoff. Gutters and downspouts should direct roof water to appropriate drainage areas. Surface water should be diverted to a storm sewer system or other drainage points. Building sites should be graded so as to drain surface water away from the foundation. The ground surface should slope a minimum of 6 inches within the first 10 feet. Drainage systems or swales are effective methods for controlling surface water, especially in areas where attaining the minimum grade is not possible. All right, so this is, again, you're going to find this on new construction, on older homes or existing homes. where the grading is not correct. And you're going to have a heck of a time fighting a builder to correct the grading on the outside of the home. So, this picture down here is pretty common, where it actually looks like there's probably not gutters on this house, because you can kind of see this line here. This is a trough likely, or the gutters are overflowing, where the either the gutters are overflowing or there's no gutters, and it's kind of creating a little trough next to the house. And over time, that water just beats down that earth and eventually creates a negative grade against the house. So um, definitely want to just make sure I always take my level. I have a 4-foot level, and anytime there's any negative grading, I just take pictures, put it in the report, and just recommend that the client just take care of it after they move in. Because like I said, a lot of times you're going to get some major pushback trying to get the builder or the seller to correct grading on the outside of the home. You'll have a better chance of getting it corrected if there is water damage or water intrusion into the crawl space or into the house or whatever. Especially, if you can find some observations that are indicative of negative grading, like efflorescence. If you see efflorescence on a foundation wall that has negative grading, that is a really good lead into, getting the grading corrected, by the builder or by the seller or whatever, and then making sure that if there is efflorescence on that block wall or on that foundation or wherever you see it, that you're inspecting the interior portion of that to make sure that water is not coming through into the into the structure of the home, the wood or the drywall or whatever, what have you. So this swale situation over here, this diagram. So I had again, I'm in a huge growth area here in my location. So we had back during the housing bubble and when was that, 2007, trying 2000, yeah, 2007, 2008, 2009, something like that. So these huge lots were all developed, and then they were abandoned because the market crashed, the bubble burst. So you had this subdivision that was already developed, and it was in a very small town, so there was very little oversight. And then a new company, a brand new, or a big builder came in, and they bought the development, and the city, and they bought it 10 years after it was originally developed. So there was crazy amounts of construction that went around this development. And then this builder came in and started building houses on their lot. The city, because it was a small municipality, did not require them to redevelop or get the civil engineer to redraw floodplains. And so the water drainage had changed massively over those 10 years. And so they built, and they had to have known that there was a problem from the moment they started building, because there was a pond adjacent to the development. And so much water had been funneled into that pond because of all the other hardscaping that had gone on with other developments, that pond overflowed every time it rained. And where they built, there's on one corner of this subdivision, 4 houses would get flooded every time it rained. The homeowner did not get a home inspection. And so we got called out to do an evaluation after the facts and to get some resolution from the builder. And so it turns out that they had to come back and they had to build swales and dig swales down all the way around these houses and provide additional drainage and concrete gutters. And so basically these 4 houses that were affected, they dug down, they put in additional drainage, and then so unfortunately what they did is they moved those homeowners to the other side of the development. They did all that work, and then they just resold the homes again. So again, you never really know what the house has been through, what you're getting into, when you come into a home. So make sure that you keep your eyes open and you just fully evaluate and don't take anything for granted. Because I would hate that something happened and if the home inspector did get an inspection on one of those houses, And nothing was disclosed to the new buyers that the homeowner or the inspector might have been held liable for anything that was not found, or whatever. I'm getting a little intense on that, but hopefully you get what I'm saying. All right. And then on this top right picture, the negative grading creates water and structural problems. Again, we have a lot of walkout basements. We have a lot of hills and mountains. So anybody that's in a hilly or mountainous area, I'm sure you're very familiar with this, where it's basically they build the house almost into the back slope, but no swales were installed, no drainage was installed, or maybe they did. They did push dirt up against the foundation. They put the sod down, but on a new construction. But over the course of the year, everything settled, and now you have negative grading coming off of that hill going right into the house. So we have an example, kind of almost this exact same picture here, where it was an existing home, mountainous area out by the lake, and the crawl space was so shallow where it went into the side of the hill, we could not get in there. My inspector that was in there, he did his due diligence. He did everything he possibly could, and he actually called out that, yes, we think that there is water damage to that whole side of the house. And there was indications that they knew that they had water issues and that they poured concrete all along that side of the house. But unfortunately, the water was subsurface, and instead of going on top of the concrete, it went under the concrete and still came into that side of the house. So we got a call, I don't know, probably 3 months after the inspection, a month after they moved in, and they were moving a huge China hutch in to that home. And when they set it down on that corner of the house, the whole floor structure dropped by like 3 inches because that whole side of the house was rotted. Our client did not blame us. He agreed. He knew that we did our due diligence. We do everything that we could, and he did not follow our instruction in the report, recommending further evaluation, recommending drainage issue, the landscaper to correct drainage issues on the outside. We even identified the concrete that was there that was likely to help stop or curb the water from coming into the home. So we did all those things. So we were protected in that. He just called us out because he was asking for help on what to do and how to get it fixed. So anytime you have any negative grading, pay special extra attention, especially in crawl spaces. All right, standard number 9, anchorage or sill plate anchorage, foundation anchorage. So to prevent walls and floors from shifting under lateral loads, anchorage to the supporting foundation is required. Wood sill plates and wood walls supported directly on continuous foundations must be anchored to the foundation. Anchor bolts must be used, as well as foundation straps, if installed in accordance with the manufacturer's instructions. Look for anchorage. All right, I'll get into some examples here in a second. So here's the details. The bolts must be at least 1/2 inch diameter. Approved anchors or anchor straps can be installed and spaced as required to provide equivalent anchorage to 1/2 inch diameter anchor bolts. The bolts must not be spaced greater than 6 feet on center. Bolts must extend into the concrete or grouted cells of concrete masonry units at least 7 inches. The bolts must be located in the middle third of the plate width. It is common to see an anchor bolt placed near the edge of a wood sole plate. The requirement for placement of a bolt within the middle third of the wood plate width allows some flexibility while providing for minimum edge distance. A nut and washer must be tightened on each anchor bolt. No loose nuts, no missing washers. There must be at least 2 bolts per plate section. The bolt must be located at least 12 inches from the end of the plate section, and the bolt must be located at least 7 bolt diameters from the end of the plate section. It is a common defect to see a bolt placed on the very end of a plate section. There are exceptions, including walls that are 24 inches total length or shorter, connecting offset braced wall panels, and walls 12 inches total length or shorter, connecting offset braced wall panels. When braced wall panels are supported directly on a continuous foundation, the wall wood sill plate or cold form steel bottom track should be anchored to the foundation appropriately. In some areas, large square plate washers are required to compensate for oversized bolt holes that are often bored. All right. So again, on new construction, I see this all the time. I would say on probably, I do a lot of new construction inspections. So, out of 30 a month, out of 30 inspections a month, I probably do, oh, probably 20 of them are new construction. And so I see, and I don't know how it gets missed. It's kind of shocking to me, that you will all the time, you'll see missing bolts, you'll see missing washers, you'll see missing nuts, or as in, well, we're also very close to Missouri. And so Missouri has, if you are not in the city limits of a town in Missouri, there is no building code, there's no licensing, there's no construction licensing, there's no contractor licensing. It's the Wild West in Missouri. It's kind of crazy. I did an inspection on a house where there was no bolt, there was no anchorage to the foundation at all. Cells were not grouted. There was I think they did have rebar to support the CMU walls, but they were not grouted, and there was no anchorage. And so we're starting to. I think I don't know if, from my understanding, the Tornado Alley is no longer that strip of states going on the Midwest. So it's now starting to expand into where I'm at. So we never had a tornado up until about 5 years ago, and we've had, I think, one a year since. So, in some area of Northwest Arkansas, and so, which includes Southwest Missouri, which is where this house had zero anchorage. So, especially if you're in a state that has where only your municipalities control code, pay special extra attention to the houses that are outside of towns, basically. So again, everything that I read about and all of the diagrams and everything that you're seeing on here, I find these all the time on new construction. Definitely on existing construction, but on new construction, it's still very shocking. Even in my areas where you do have code inspections, a lot of times, because building is so crazy here, code inspectors are a lot of times what we call doing coffee shop inspections, where they drive by, they say, "Oh, looks good," and they drive on without actually ever inspecting anything. And we do have very stringent code inspectors here, but again, I guess it probably depends on if they had a bad day or not, or what's going on their schedule. But definitely pay attention in all aspects to foundation anchorage. Notches and holes, standard number 10. So notches can potentially reduce the structural integrity of solid lumber joists. Therefore, there are limits on size and location of notches to solid sawn lumber members. Notches in solid lumber joists, rafters, and beams should not be longer than 1/3 of the depth of the member. That's the D3 that you're seeing on the diagram, and should not be located in the middle third of the span. So you got the middle third of the span, and D3. Let's see. Sorry, I lost my place. Okay, so notches at the ends of the member should not be more than 1/4 of the depth of the member, D4. Notches located in the outer thirds of the member should not be more than 1/6 the depth of the member. If engineered wood members such as trusses and I-joists are notched, the effects of the notches must be planned and approved by a structural engineer who designed the member. So before I keep reading here, so if you ever see that, I think so when you have an I-joist, a manufactured I-joist, and you have, I think it's called the bottom chord and the top chord, kind of like in trusses, that can never be cut unless it was pre-approved by a structural engineer. So you'll see this all the time around plumbing, just like you see where they notch a joist out for the toilet or whatever. Just pay special attention to the plumbing areas when you're looking for, incorrect notching or boring of structural members. Bored holes in solid lumber members can have the same effect as notches. The bored hole can reduce the structural integrity of the member. The diameter of bored holes in solid lumber members should not exceed 1/3 the depth of the member. Holes should be at least 2 inches from the top or the bottom edge of the member and should be at least 2 inches from any other hole or notch in the member. Again, so plumbing, they are especially, plumbing penetrations are especially susceptible to notching and boring, incorrect notching and boring. So make sure you're, when we have a crawl space that is fully insulated, where the floor is fully insulated, we're not going to pull down all the insulation, everywhere and go and check everything. We check the susceptible locations. So we'll pull the insulation back around plumbing penetrations, around the perimeter of the house, anywhere that there is any kind of abnormality in the floor structure. We pull the insulation back in those locations to check for damage. And a lot of times, like I said, or especially with plumbing, you're going to find where it's kind of, and unfortunately, this is prevalent in our industry, "it's not my job" kind of quote, where somebody bores through something or somebody notches through something or cuts through a joist, and maybe they did tell somebody, or maybe it got forgotten about, but then nobody ever goes back and re-supports that splice or that cut that was done. So make sure you're doing your due diligence, and so when I do an inspection, I snake through and I look in person, within 3 or 4 feet of every structural member of a crawl space. And that is a lot of work, and it can really, you get your abs working really good. You're trying to inchworm all the way around a crawl space, but more so, and you'll see this in other classes, where if it's hard for a contractor to get to, if it's hard for you to get to, that means it's hard for a contractor to get to. So a lot of times those hard to reach places are kind of ignored or abandoned or forgotten about. And so that's where a lot of times you're going to find these items that have not been installed correctly. Again, it's kind of the same thing with the foundation or the foundation anchorage. If it's hard for you to get to, that means it's hard for the contractor to get to. And a lot of times that's where you're going to find shortcuts and you're going to find damage and stuff that was not done correctly. So, okay. Let's see. Oh, also, and just before I keep going here, this diagram also applies to decks. So keep that in mind with decks. And I'm actually doing the deck webinar next week too. So we'll go over all this information because we have the same diagram in the deck webinar. But keep this in mind for decks too. I guess more than likely what you're going to find most of is, I would say, incorrectly splicing. Not a lot of boring. I don't find a lot of incorrect boring. A lot of times you'll find incorrect boring inside the home, not necessarily. So like if you have a finished basement, you'll find probably incorrect boring or incorrect notching in finished basements on the floor joists going from the basement or from the first floor to the second floor. So you'll find that kind of stuff. Drop ceilings, make sure you're popping those drop ceilings and looking at at least, if you can, the main structural members and making sure that they're not notched or incorrectly bored. Garages, modified garage, or garages that used to be carports and that have been added as are now garages. So because the carport was never intended to have a garage door opener, and so the ceilings can be lower. or the framing and everything is a little lower. And so, or maybe you have a main structural beam that goes, end to end in your garage, and or that used to be a carport or whatever. But that's where you're going to find where the garage door opener contractor might have modified the structural members or the joists or the beams incorrectly to be able to get his garage door opener high enough so that cars can enter and it can be used functionally. So that's where you're going to find a lot of incorrect notching and boring in those locations. And like I said, in basements and sometimes that's so. Next. All right, so masonry chimneys. A masonry chimney should terminate some distance above a roof in order to provide adequate upward draft in the chimney. Masonry chimneys should extend at least 2 feet higher than any portion of the building within 10 feet horizontally. The minimum height of the chimney should be 3 feet. Cleanout openings should be provided within 6 inches of the bottom of the flue within the masonry chimney. There is an exception for cleaning a fireplace at the fireplace opening. The upper edge of the cleanout should be located at least 6 inches below the lowest chimney inlet opening. The height of the chimney's cleanout opening should be at least 6 inches and should not be made of combustible material. Any portion of a masonry chimney located in the interior of the building, such as an attic space, should have at least 2 inches of airspace clearance from combustibles. As heat is transferred through the masonry material, any combustible material in close proximity to the heated walls may reach the point of ignition. The airspace helps in the dissipation of heat. Chimneys with a dimension parallel to the ridge line greater than 30 inches that does not intersect the ridge line should have a chimney cricket. The cricket should be flashed and counterflashed in the same manner as a normal roof chimney intersection. All right, so gonna go into some details. So first, the chimney heights. More than likely, because existing chimneys or older chimneys been around for a long time, right? So if you have a home that has an older home that has a chimney, more than likely it's been there for a while. And you're probably not going to have these clearance issues with a home that has an existing chimney, because more than likely, if it didn't meet specific clearances for the height or whatever, they would have experienced an issue long time ago, and they probably would have likely fixed it by now. The issue comes from when you add additions onto a home. So say there's an addition on this edge over here, and it goes higher than the chimney, and let's say it's within 10 feet of that chimney, because we don't know the distance from the chimney to the rake edge over here, and now you are not in compliance. So you want to pay special attention to chimneys, especially on houses that have had additions since the original construction of the home. And that's where you really want to pay special attention to these clearances or these distances. Let's see. The other thing, let's see. Okay, so when you're in the attic and you're inspecting, you're in this attic over here, it is very common to find the framing attached or built directly around the chimney flue inside the attic. So again, exactly what I had mentioned earlier is that combustible products have to have a clearance from the chimney to make sure that nothing heats up to a point, or it doesn't necessarily have to heat up, but it can dry out. Over time, just the heating and consistent heating and then cooling, and consistent heating and then cooling, and eventually that wood that is around that is framed around that chimney, or whatever material is around that chimney, and eventually just really gets dry and it's like kindling. And so eventually at that point, when something dries out so much, the ignition level of that material is lowered. And so while it might have been okay to install when it was in, it might have been okay to put in place when it was first installed, but over time it gets extremely dry, and now you basically have kind of a little tinderbox there. And you're building a fire inside of a home. You want to make sure that you are protecting yourself. If you've ever inspected a home where the house has fire damage, a lot of times it comes from the chimney, and specifically for those reasons where maybe they didn't clean it enough, and then the entire inside of the chimney has creosote buildup, and so the creosote buildup ignites on the inside of the chimney. Well, that just exacerbates the heat that is being put off by the chimney inside the home, and it starts to catch things on fire. Even if the chimney flue is not on fire, it's hot enough to ignite the items on the outside of that chimney. So you want to make sure that you have those distances and those fire rated materials around the chimney. So if you're inspecting a house that has those materials installed, look for the darkening, like if there's wood there, and make sure, see if it's dark or not, and see if it's kind of heated up and has kind of scorch marks and stuff around it. And that'll tell you that, maybe they might have had a chimney fire at one time, and it didn't get into the house, but it made the framing around the chimney inside the attic hot enough for it to scorch. And so that, again, that's all of these are things that you should be looking at when you're doing the attic inspections, to make sure that your buyer, your client, is going to have a safe home. Attic access. So mechanical equipment in attic space or in crawl spaces should be accessible for service and removal. In addition to an adequately sized access opening, a passageway should be provided. In an attic, the passageway should be made of solid flooring. There should be an opening from the space and a clear, unobstructed passageway large enough to allow removal of the mechanical appliance. The passageway should be at least 30 inches high, at least 22 inches wide, and not more than 20 feet in length when measured along the center line of the passageway from the opening to the appliance. There are some exceptions. The passageway flooring should be at least 24 inches wide. A service area is required in front of the mechanical equipment with a minimum dimension of 30 by 30 inches, 30 inches by 30 inches. A light fixture should be installed to illuminate the passageway of the mechanical appliance. A control switch should be installed near the entryway to the passageway. An electrical receptacle should be installed at or near the mechanical appliance to allow for safe and convenient maintenance and service of the appliance. And the rough framed opening to the attic area should be at least 30 inches by 22 inches. If the opening to the attic area is installed in a ceiling, there should be at least 30 inches of vertical headroom in the attic space measured above the access. So I'm just very blunt. A lot of these things you're going to call out on existing and new construction. We did a new construction inspection where I am, props to the HVAC guy. I don't know how they got how they got the equipment in. I'm sure they had to assemble everything piece by piece in this attic, but basically there was a truss system, and I think it was a DR Horton house, and somehow this HVAC guy was able to wedge the HVAC unit in between the truss webbing, and was completely inaccessible. The front of the unit was facing towards the outside of the home, and there was absolutely no way to get to the unit. I don't like it was mind-boggling that it was allowed, that it was installed that way or whatever. So, and then in addition, you're going to find all the time, especially on existing construction, but definitely on new construction, you'll find inadequate access or walkways or landings in front of the units. So, you want to make sure that you have, not just for you, but for any contractors who go into that attic after you. What you don't want is where somebody buys a new house and they go in, and you didn't call out that and not saying that you're going to get in trouble for this, but you just don't want your client to experience this where there is no attic access, there's no walkway, or there is attic access, but there's very little walkway, there's very little workroom, or the HVAC system is in a compromising situation or is a compromising configuration. And then the HVAC guy comes out and tells the homeowner, "Oh, I'm sorry, I can't service your equipment. There's not enough room. There's not enough space. Whatever is going to happen." And then the homeowner has to pay for upgrades to be able to, provide better access to that appliance. And then now that homeowner has additional costs. Um, so let's see. Again, you'll find so not only walking access to the appliance, but also headroom. When they put these attic accesses on an exterior wall, and the truss or the rafter is coming right up here, and you have to when you push up the attic access and you immediately hit something, and then you have to and then you slide over that access door, then you have to if you get up into that attic, which in that instance you technically not required to, but if you do decide to get up into that attic, now you have to kind of very carefully pull yourself up into that attic space without hitting your head on the nails on the roof decking or causing more damage or damaging the trim on the attic access as you go in. You just you want to make sure that everything is clearly accessible for you and for everybody else. Let's see what else was here. The control switch. The so not that there's a requirement for this. The code just says that there has to be a a switch, a deactivation switch, or some type of form of activation or deactivation. So that could be a switch, that could be pulling a plug. But a lot of times you'll have the attic access light and the appliance switch could be right next to each other, could be on opposite sides, and there's no clear understanding of which switch does what. And so if you go and you think that you're switching on the attic light and you're actually switching off the HVAC system, which is why you went up into the attic in the first place, then in those instances, oftentimes if I see that, I always carry a marker in my bag, and I will just write HVAC on there, on the switch outlet, just to make sure that that doesn't cause a problem in the future. Because then in those instances, if I did accidentally switch off the HVAC unit, a lot of times you have to get back out of the attic, go and turn the HVAC system off, because I've had systems that won't cycle. Once you turn the system off and turn it back on, and you have the HVAC on the thermostat, either it takes 10 or 15 minutes for it to cycle through, or it never actually cycles through. And so you have to go down, turn the unit off, wait a minute or two, turn it back on, and then go back up into the attic. So it's just an extra 15 minutes that you having to spend going up into the attic. So just pay special attention to those switches and where they're at and what they actually operate. Let's see. So I think that was all the bulleted point stuff. All right, let's go to the next slide. Clothes dryers. All right, so the clothes dryer exhausts pose a different problem compared to other exhaust systems because the air they carry is damp and infused with lint. The exhaust of a dryer must vent outside and not discharge into an attic or a crawl space because the wooden structural members could be affected. Exhaust vents should have a backdraft damper installed to prevent cold air, rain, snow, rodents, and pests from entering the vent. The length of the clothes dryer exhaust ensures that the dryer exhaust blower will be able to push sufficient air volume to take away damp air and lint. The length can be increased only when the make and the model of the dryer is known or when an approved blower fan calculation is provided. The maximum length of the exhaust duct does not include the transition duct. Transition duct means from the dryer to the actual dryer vent that is that terminates to the outside. Screens are not permitted on clothes dryer exhaust vents because they can trap lint and other debris, which poses a fire hazard. The maximum length of a clothes dryer exhaust duct should not be greater than 35 feet from the dryer's location to the wall or roof termination. For each 45-degree bend, the maximum length of the duct is reduced by 2.5 feet. For each 90-degree bend, the maximum is reduced by, and I think it's 5 feet. 5 feet. All right, so there's a lot to talk about here. So, um, you will see all the time where contractors they don't really differentiate between bathroom exhaust vent caps and dryer exhaust vent caps. So a lot of times they'll just buy bulk and they install them everywhere. So you'll find you'll find bathroom exhaust vents on dryer exhaust vents, which the bathroom exhaust vents should have a screen on them because they are not expelling, they're not expelling lint, and you don't want the potential for a bird to make a nest in there and then force that flapper closed. So, and this is what I do. Again, you guys don't have to do that. I'm not suggesting you do this, but anytime I find a dryer vent, a lot of times they're white. You'll find a white dryer vent and it'll have that kind of mesh plastic cap on it. And if anybody's been living in the house for any period of time, more than likely that mesh cap is completely clogged with lint. So in those instances, I just remove it and I get rid of it. For them, and I don't call it out. Now, for me, I always try to open the flapper and use my phone and take a picture on the inside to see how much lint is on the inside of that dryer vent, because it's one of those out of sight, out of mind things where people don't address the dryer lint until their dryer is not drying correctly. A lot of times, that's usually what it is. The dryer's not drying correctly. They can't figure out what's going on. They call a service tech out, and the service tech goes and they look at the exhaust port or the termination port on the outside, and it's completely clogged full of lint. And then that's when it gets cleaned. The other thing too, you're going to find often, and this happens. This happened in my area up until about 10, 15 years ago, where they were using PVC for dryer vents. PVC or I can't think of the green pipe. They usually use it for septic systems. I can't think of the name of it right off the top of my head, but they would either use PVC or that green pipe as dryer vent extensions. And again, you cannot use plastic. So the issue with plastic dryer vents is creates a static charge. SDR. Thank you, Richard. The plastic dryer vents, the PVC or SDR, when that vent travels through and it gets dry, when the air gets when the air comes out of your dryer, it's very moist and there's a lot of lint on it. And as it goes down all the way to the end, it starts to dry out, and then it starts to, because it is moist, it actually starts to adhere to the other dryer lint and to the walls of the plastic pipe. And so as that travels through, it actually creates a static charge. And that static charge could ignite at some point. That is and that's exactly the reason why PVC and SDR is no longer acceptable to use as dryer vent extensions. But like I said, we see them here. I mean, any house that's 10 years or older, more than likely is going to have a PVC or SDR dryer vent. So keep an eye on that. Keep an eye on your covers. And so Rick said 1,500 closed dryer fires in the US per year. Yeah, so you want to, again, so kind of like how fires are most commonly start in the garage, because that's where you keep your combustible materials. That's where your car sits. It has a super hot engine. That's a lot of times where you have gas supplies for gas supply dryers or water heaters or furnaces if they're in there. And then you have gas products, for your lawnmower and all that kind of stuff. So dryer vents are kind of in that same realm where you want to provide the most protection for your client. And the last thing that you want to hear is about a fire that's happened on a house that you've inspected, no matter how old it is, or no matter how long ago the inspection was that you did on the house. So anytime that I hear about a fire, a house fire going on, I always go and check if it's in my database that I inspected that house, because that's the last thing that I want. But um, so the other thing too, especially on this right picture, this happens very commonly on DIYers and house flippers. They don't know code, they don't know installation instructions, and so they will do flexible vented or flexible dryer vents that were only intended for the connection between the back of the dryer and the wall or the floor. They are never intended to go through a wall or into the attic or through the floor or anywhere else. Because it takes about probably 1 year before it gets clogged, and then they can't be cleaned, and then they have to be replaced. But it's one of those situations, out of sight, out of mind, that they're not going to do anything about it until it causes a problem. And like this picture on the right here, the it's probably never going to get found because it's not exhausting to the outside, and you don't see those clumps of lint that are falling in the yard, or you don't have that vent that has lint all the way around it, because all the lint is being distributed into the crawl space. And if you've been an inspector for any period of time, I'm sure, like I have, we've all crawled through a lint riddled crawl space because of this exact situation on the picture. Let's see if I hit all my topics here. Screens, lengths. Lengths are very difficult to evaluate. So, I guess for me, as long as, if the dryer is on the far side of the house and my dryer vent is on the opposite side of the house, then you got to start looking for, well, is there any lint even coming out of there? Because of the distance, maybe it's clogged 10 feet back or whatever. So if you go to an existing home and there's no dryer lint in the exterior dryer vent penetration, definitely make sure that it wasn't recently cleaned or whatever. But if it's definitely in use and you can tell it hasn't been cleaned, then maybe it's too long or it's collapsed. So here's another indicator, another issue that we've had, and I'm sure everybody's seen this, where most dryer vents are now exhausting out of the roof. They're doing that because the way that they're configuring homes is they're putting laundry rooms in the middle of the house now instead of on the outside of the house. For whatever reason, dryers or laundry rooms that are on the outside of the house, I'm still seeing dryer vents terminate through the roof, which doesn't make a whole lot of sense to me. But the fact is it happens. So they used to do sub slab dryer vents, where they would pipe a PVC or metal pipe through or underneath the slab, and then it would come out, and then it would pop up like I want to say like a reverse P trap. It would pop up from underneath the slab out the side of the house. So what's happening with those, and why they went away from those, is over time, water eventually gets into those and when they're under the slab, and so water gets in them, and then they just continue to collect. They collect more and more lint, and they're easy to clog, and then it kind of becomes a stagnation issue where you can get a nasty smell, or bacteria is growing in there. And then or other times where those sub slab exhaust vents have collapsed, and so then you have to install a new one. And so anymore, even though you're fighting against gravity and pushing that lint out of the roof, that is the most common installation that you're going to find on new construction. The other thing that we recommend for clients is that, one, you definitely try to find which vent on the roof is going to be the dryer vent, because where it terminates out the vent is going to determine how easy it's going to be to clean. So a lot of times those, you'll get those vents and they terminate, halfway up the roof, and it's on an 812 pitch, and there's no way that the homeowner can get up there and clean that out. So then they're going to have to hire somebody to do it. And so I always try to identify. Now on new construction, it can be very difficult because, like I said, on the bathroom exhaust vents versus the dryer exhaust vents, they will a lot of times use the same vent cover. And so trying to determine which vent is the dryer and which vent is the bathroom exhaust can be a challenge. So I try to do that for my clients to show them, hey, this is your dryer vent that, because of the pitch of the roof and how difficult it's going to be to get up there, I would recommend hiring somebody and just scheduling it at, once every 2 years, once every year, depending on how often they use their dryer, how many people are in the house, and all that kind of stuff. So, um, so just, I would recommend, that's what I recommend to my clients. And so, yeah, take that as a, all right. Let's see. Anything else I remember on that? I don't think so. Um, all right. Standpipes. So, um, all right. Access to all standpipes, traps, and drains should be provided for cleaning and rotting. The standpipe itself is often concealed, but there must be access at the point of the indirect connection. Let's see where we at. A standpipe can serve as an indirect waste receptor. To prevent overflow, the height limitation is necessary to provide some retention capacity and head pressure. The height limitation controls the velocity of the waste flow at the trap inlet. The limitation is necessary when a high rate of discharge enters the indirect waste pipe, such as that from a clothes dryer. Excessive velocity will siphon the trap. The 2018 IPC, International Plumbing Code, Chapter 10, or that's from the 2018 IPC Chapter 10, sorry. The laundry tray tub or the waistline is permitted to connect to a standpipe for the automatic clothes washer drain. This standpipe should not be less than 30 inches as measured from the crown weir. The outlet of the laundry tray should not be greater than 30 inches horizontally from the standpipe trap. Standpipes must be trapped. The standpipe height should be at least 18 inches and no more than 42 inches above the trap weir. The illustration shows the trap weir. So you can see the trap weir is here, right? So I had a client, this was probably 5 years ago, but I had a client moved into a home was existing, and when they installed their washer, as any normal homeowner would, they just take that pipe and they shoved it down the pipe as far as it could go. And then they called me because they had sewer gas smell coming into their laundry room, and they thought that I, missed something. They couldn't figure it out or whatever. And so I went over there, and sure enough, the force of the water from the pump of the clothes washing machine and how far they pushed the hose, the drain hose, down into the pipe, pushed the water out of the trap, and so they were getting sewer gases coming up into their laundry room. So you'll also, so that's just one instance, but on new construction, it is very common to get a sewer smell coming out of this the drain line for the washing machine, because that drain is not primed whenever they install it. Whenever they open that knockout, and so say they get their certificate of occupancy, you do your inspection, they move in a week later, or 3 or 4 days later, or whatever, or even in the walkthrough, I had this happen the other day where we had a sewer smell coming out of the laundry room. They're like, "What is that?" And I was like, "Well, the washing machine drain has never been used, but the rest of the plumbing system has been used." Um, so you have waste, you have effluent in the system, and there's nothing to block it. So nothing to block it coming out from that dry trap. So you get that. Um, let's see. What else was? All right, I think that's the standpipe. So you'll find a lot of times you'll find exposed standpipes in garages where the washing and dryer, like in older homes, when the washer and dryer in the garage, and you have an exposed standpipe out there. So you can see kind of what inside the wall looks like on a new construction home. So typically, all of this that you see right here is inside is inside the wall on a new home versus versus on an existing home where they'll have it exposed like in a garage or something. So the other thing I want to keep, I just wanted to, this really doesn't have anything to do with standpipes, but every time I train a new inspector, and we're walking around the outside of a home and we're looking for the main waste clean out. And, the main waste clean out, 95% of the time is always going to be in the ground. Um, and so when you see those clean out ports that are actually installed on the side of the home, we always tell, they always like, oh, well, there's the clean out. Well, that's the clean out for that specific appliance. So a lot of times that's going to be your shower or your bathtub or whatever. And so that's when we talked about the access to all standpipes, traps, and drains should be provided for cleaning and rotting, because when you have a bathtub that has no access either underneath or from an access door, and that drain has been trapped below the slab, well, you have to provide an access to be able to get to that if there's a clog there, so that you can rot it out. So just keep that in mind. That's what those guys are. All right. TPR valve discharges. An appliance used for heating water or storing hot water must be protected by a relief valve. A combination temperature and pressure relief valve or separate temperature relief and pressure relief valves prevent water heaters from exploding. They are emergency devices. They are not intended to continue to function continuously. The pressure relief valve should be set to open at least 25 psi above the system pressure, but not over 150 psi. The relief valve setting should not exceed the tank's rated working pressure. Temperature relief valves should be installed within the top 6 inches of the tank. The valve should be set to open at a maximum temperature of 210 degrees Fahrenheit. Discharge from a relief valve should be immediately investigated. A discharge indicates that something is wrong with the system. The discharge point should be conspicuous. The termination of a relief valve discharge pipe should always be visible and conspicuous. An air gap is necessary to prevent backflow and contamination of the potable water system. The discharge pipe must not be reduced in size and must not be less than the size of the relief valve outlet. A reduction in size will act as a restriction and would impede the flow of the discharge. Relief valves must not be exposed to freezing temperatures. The slow drip of a leaking valve in freezing temperatures would cause ice to form and would restrict the discharge and disable the valve. 13 requirements for a discharge pipe serving a TPR valve. The pipe should not be directly connected to the drainage system. So actually, I'm going to comment on these as we go through them. So the pipe should not be directly connected to the drainage system. That is to ensure bacteria does not travel up the waste system and up into the temperature pressure relief valve and into the water heater. So that goes the same thing for having an air gap from the discharge pipe into a drain. You want to make sure that there is no possibility for bacteria or any organisms that is in the sewer or in the waste system to jump from the waste pipe into the potable water system. Well, yeah, 2, just hit on that. 3, the pipe should be constructed of materials tested, rated, and approved for such use. So on this, you're going to find all kinds of materials. I found water hoses I've seen for discharge lines. You'll find a lot of times, and I don't know how or why this became common, but I've seen it a lot on older homes when you have a 20-year-old water heater where you'll have you'll have the discharge, the temperature pressure relief, the TPR valve, which for the life of me, I think it's 1.5 inches. The size. Oh, sorry. Let me. Uh-oh. Let me get back here. Okay. We can go here. Um, Gosh, I forgot the outlet. I have one around here somewhere. So anyway, um, a lot of times you'll see reductions, and it was installed by a plumber where they take a very small copper pipe, and it's probably 3/4 inch maybe, and they put an adapter on it and they attach it to to the end of the TPR valve. And again, and I find this all over my area in existing 1980s homes and older. I always call that out, and a lot of times. Uh, and I'm probably getting ahead of myself, but that pipe, if there's a crawl space, a lot of times it just goes through the floor and then just disappears into the nether. So 3/4 inch. Thank you, Rick. Appreciate you. So anyway, 3/4 inch on the sides, but they'll put a 1/4 inch pipe and adapter on top of it. So you got that, and then well, I'm gonna go through the rest of this. So the pipe should not be smaller. The pipe should not be smaller than the diameter of the outlet of the valve served and should discharge full size to the air gap. The pipe should not have valves or T-fittings installed. The pipe should not have a threaded end that will allow capping. The pipe should serve a single relief device and should not connect to piping serving any other relief device or equipment. So if you have two water heaters side by side that are in series, you cannot pipe those two together and then pipe them into the drain. They have to be individually piped. The pipe should discharge to the floor, to an indirect waste receptor, or to the outdoors. Where discharging to the outdoors is in areas subject to freezing, discharging pipe should first be piped to an indirect waste receptor through an air gap located in a conditioned space. Definitely, this is definitely new, a new standard, because you find a lot of times on the older homes, this is not happening. They just directly pipe to the exterior. So we did a large apartment complex, and so if you do multifamily, and so it was like a 40 some door apartment complex, and inevitably, just through the nature of apartment complexes, you're going to have a range of equipment, that is a range of age of equipment installed. And so you'll find, and a lot of times when a tenant has a problem, the they don't notify the landlord or the manager or whatever. And so we were doing the inspections, and it was wintertime. I think it was December, and we found four frozen TPR valves on the outside of the apartments. And so because it was frozen on the outside, that water was not, it was not able to discharge, and it was just that the TPRV valve was leaking, so it wasn't activating, it was just leaking. But by the time it got to the outside, the water froze, and all that water was backing up into the system. Luckily, I don't think, it wasn't causing any problems or anything like that. But had that valve needed to activate, if the unit started to malfunction, then they would have had a major problem. Um, so we're talking. I'm looking at the comments over here by Rick. There, so um, there's a new pipe out there that you can find at Lowe's and Home Depot, and on it looks like PVC. It's white. It looks just like PVC. So just like if you're trying to identify exterior or I'm sorry, uh, pressure, like, okay, so pressure treated wood, right, has to have certain connectors to make sure that the connectors don't deteriorate, because the treatment in the wood will degrade the material, right? So kind of the same thing that we're talking about here is that it's really hard to exactly determine what material is without reading the labeling on the material. So The discharge pipe that I'm talking about, it looks exactly like PVC, but on it, it says specifically, rated for temperature pressure relief valve at this temperature, at this pressure, so on and so forth. So where you used to be able to tell, just like with screws and nails and stuff, you used to be able to tell, oh yeah, that is definitely not rated for, or that's definitely not galvanized, or that's definitely not rated for treated wood. You may or may not be able to tell the difference on discharge pipes. If it's plastic or it's PEX or PVC, if you really want to dive in deep, you really need to pull up the manufacturer and see what it's rated for. Because the materials change all the time, the colors change all the time. With plastic being introduced into so many materials now, that you can use to coat, that you can use for the piping or whatever. If you really want to pay special attention to those things, you need to be able to try and find the manufacturer, the model number, or whatever, or look for the labeling and see exactly what the labeling says and if it is applicable to that situation. The pipe should not terminate more than 6 inches above the floor or the waste receptor. So that is for, if the temperature pressure relief valve pops off, you're looking at, what did we say, 210 degrees and 150 psi. So your house water should be anywhere from 60 to 80 psi. So if you're looking at 150 psi and you're looking at 210 degrees, you're looking at steam and extremely hot water. So if that valve is popping off because the water heater is malfunctioning, and that valve or the disconnect, or I'm sorry, the extension, the pipe extension is more than 6 inches off the ground, and you have a child, say just for the sake of argument, let's say the water heater's in the garage and it's currently acceptable to terminate the temperature pressure relief valve pipe to the garage floor. So if you have a child that is playing around your water heater, because nothing happens to the water heater, it's fine, but all of a sudden the water heater pops off and it comes out at 150 psi and 210 degrees, and your child is over there playing, and because it's 6 inches off the ground, they're now scolded, or scalded, not scolded, or you have an animal, or say the temperature pressure relief valve extends to the outside and it terminates more than 6 inches off the ground, and your dog is over there, you fenced off that part of the house, and now that's where your dog hangs out or whatever, and that TPR valve pops off and your dog is sitting right next to it. Now you got to take your dog to the vet because they've been burned and scalded. So those distances are very important. The pipe should discharge in a manner that does not cause personal injury or structural damage. So that structural damage, again, that kind of goes back to the temperature pressure relief valves, very common. I mean, and they still do it in new construction today, where they terminate the TPR valve in the crawl space. So in the wintertime, say you have all your crawl space vents blocked off, so there's no airflow. Your TPR valve is terminating in the crawl space. You just created a sauna for your wood structure. So, one of the main things I always put in my reports, and I have it where I have to answer this in my report, is where does the temperature pressure relief valve terminate? If I cannot find where it terminates, it goes in the report as needing a plumber to identify. Now, I'm not recommending this. I don't do this. I would never recommend this to anybody, but I've heard people manually popping off, this is a activation switch, and they'll manually activate that to make sure that it activates. I do not recommend that, because once you activate that, a lot of times it will leak after that, or it will activate continuously and you can't turn it off. So I don't recommend that, but that is generally, that's how a plumber is going to find it, because a plumber has the tools and the knowledge and the experience to be able to replace that valve if they need to. So I've seen valves where they ran through a wall, but they never exited the wall, or they go sub slab and then they come out and so much landscaping has been placed on top of it over the years that it's buried. Well, then that pipe or the water at that pressure and that temperature can't expel fast enough because it's being clogged by the landscaping outside. And so all of that backs up into the unit, and the tank can explode or rupture and then cause interior water damage, or I don't know if you guys have ever seen the video of a water heater exploding, but it is super impressive. I would definitely go to YouTube if you have an opportunity and look up water heater explosions, because it's very entertaining, and the damage that it can do to a house is shocking. Um, let's see, the pipe should always flow by gravity. So for whatever reason, maybe, and I guess a lot of times where you'll find that the temperature pressure relief valve pipe will actually go uphill is where the water heater is shorter than the one that was originally installed. And so when it's shorter, now that temperature pressure relief valve came out of the wall here, but now you have a shorter water heater, and so now the pipe has to go up to meet the existing the existing pipe, and so a lot of times the only repair for that is either opening the wall up and pulling having a plumber open the wall up and pulling the pipe down, or raising the water heater up on a landing or a pedestal or something like that. Um, so anything that can stop the water from flowing by gravity easily can potentially lead to the tank rupturing. So expansion tanks. When a water heating appliance is connected to a water distribution system, migration of heated water into the water distribution piping is possible. In typical water distribution systems without some type of pressure relief, heated water will expand into the water service line and into the public main. If the expansion is not relieved or accommodated in the system, high pressure can develop that can damage pipe components and the water heater source. For water service pipe sizes up to and including 2 inches, a device for controlling pressure shall be installed where, because of thermal expansion, the pressure on the downstream side of the pressure reducing valve exceeds the pressure reducing valve setting. A device for controlling pressure should be installed in a system that has a water heating appliance and a backflow prevention device, check valve, or other device, because thermal expansion will cause an increase in pressure. All right, so expansion tanks are taking an interesting evolution. So it's kind of going backwards in a way. They kind of started out with an inline pressure reducing valve, or I'm sorry, thermal expansion valve, and then they evolved into this big tank expansion tank, and now they're going back to an inline expansion valve. So you may or may not see this big tank anymore, but you may see a pressure reduce or a pressure or a thermal expansion valve that has a drain coming off of it if the pressure gets too big. So it's kind of like a temperature pressure relief valve, but it's for pressure, and it's inline, and it'll have a little drain coming off of it, going a lot of times into the same drain that your temperature pressure relief valve is going into. So so you got that, and then so where it talked about a device for controlling pressure should be installed in a system that has a water heating appliance and a backflow prevention device, check valve, or other device. So when we're talking about, and usually this is on uh, uh, tanked systems, right? So on a solo, if you just have a tankless water heater without any check valves or anything like that, then technically you don't need a thermal expansion tank, because you don't have a tank system. So the tank system is what provides the pressure. But when you introduce, let's say you introduce a hot water, oh gosh, I just lost the name of it. So a hot water circulation pump. So where you circulate that water to the farthest fixture and it comes back, so you have continuous hot water at your fixtures. When you introduce that into a tankless water heater, then you do have to have a thermal expansion, because you've installed that uh, uh, that water circulation pump, you've essentially created another closed system. And so that heated water has to have some place to expand to. So to keep that in mind, when you're inspecting a water heater, if you don't have, and you might have other systems on there, but this is what I come across most often. If you have a tankless water heater system and no hot water circulation pump, you don't need thermal expansion tank or a thermal expansion device. But when you do introduce an item that will make the system a closed system, then you do have to introduce a thermal expansion device. I had a long fight with plumber and a builder on that one, so I got very versed in that aspect. All right. So expansion tanks, roof vents. All right. Most roofs are not designed for occupation, so the main concern is to simply vent the gases and the odors above the roof. If the roof is used for a purpose other than weather protection, such as a deck that can be occupied or an observation platform, the vent extensions should extend above the individuals occupying the roof, at least approximately 7 feet above the roof. An open vent pipe that passes through a roof should extend at least 6 inches above the roof if for snow accumulation. If it's expected at various times, the vent height should be increased so that the vent pipe will be at least 6 inches above the anticipated snow accumulation. The height in snowy areas is often determined by the local building officials based upon local information. So you have well-meaning homeowners who don't really understand plumbing realistically, and so sometimes I've seen homeowners come in and put a cap on top of the roof vent. And my assumption there is that one, they think that by putting a cap on, they don't want to, because they don't know how the plumbing system works, they think that they want to limit the amount of rainwater getting in, or maybe they have birds or squirrels or whatever getting in. And instead of putting on a vented cap, they put on just a solid cap, and then they essentially reduce the capabilities of the plumbing system to drain correctly. So you're going to find all kinds of different things on roof vents. You'll find vent caps, you'll find solid caps. You'll find vents that are terminating directly underneath the soffit, which is not allowed. And a lot of times that only happens when you have an addition. So you put an addition on, and for whatever reason, and then instead of moving the vent pipe, they just build right next to it. And now that vent pipe terminates directly below the new roof, soffit. So sometimes you'll find that caps, obviously, and for whatever squirrels, I've seen squirrels love to chew on PVC. I don't know why, but sometimes you'll see squirrel chews through the PVC pipe, so we call that out. And now I'm getting kind of on the roofing section here because I want to. But these boots, oftentimes you'll find these boots are damaged, either from weather or being cut too large. We see this a lot on new construction where they cut the boot, the rubber boot too wide, and instead of putting a new boot on there, they'll just take a load of silicone, and then they'll just silicone the crap out of that intersection there. So that's very common. Like I said, the just deterioration from UV and sun and rain and just the elements. You see those. You'll see where these vent flashings. Now, some of these vent flashings, if you read the manufacturer's installation instructions on some of them require mounting at the bottom. Some of them don't require mounting at the bottom. So be wary when you're calling that out. Make sure they're all secured. They're not, flapping in the wind. They're not lifted up. If there are nails on there, make sure that they're sealed. Let's see, what else? Make sure you actually have a vent boot instead of just tar, like roofing tar and mastic. Let's see. The distance is, so I'm in an area where we don't get a lot of snow. If we do get snow, it's like 2 or 3 inches. So we don't really have to worry a lot about, the 6 inch, 6 inches above the roof. We definitely will call that out as being a recommendation, but because we don't get roof or snow here, it's not a huge deal for us. let's see, I was going to mention one other thing, but all right, I guess that's it on there. Traps. So in general, each plumbing fixture should be separately trapped by a water seal trap. A trap or water seal keeps sewer gases from emanating out of the drainage system. A trap is the simple U-shaped pipe arrangement. The shape offers minimal resistance to the flow. The water seal prevents sewer gases and airborne bacteria from entering the interior air of the building. Traps shall have a water seal of at least 2 inches and at most 4 inches in depth. Traps for floor drains should be fitted with a trap primer or should be of the deep seal design. Traps should be level with respect to the water seal. Traps should be protected from freezing. Trap seals should be protected from siphonage, aspiration, and back pressure by an approved venting system. The only type of fixture trap permitted is the P-trap. All other types, including bell traps, drum traps, S-traps, and traps with moving parts, are prohibited. You will still see them, especially on existing construction, especially S-traps. S-traps were very common. The vertical distance from the fixture outlet to the trap weir should not be greater than 24 inches. The limitation of the vertical distance is designed to control the velocity of the drainage flow. If the trap is located too far from the fixture, the trap may self-siphon the water out of the trap. The horizontal distance from the fixture outlet to the trap weir should not be greater than 30 inches, measured from the center line of the fixture outlet to the center line of the inlet trap. It is desirable to locate the trap as close as possible to the fixture to avoid the need for a long drain pipe on the inlet side of the trap to be installed. There will not be enough flow energy to move waste if the horizontal distance exceeds this limit. Fixtures must not be double trapped because of the unnecessary additional restriction of flow and the increased potential for stoppages. Double trapping can cause air to be trapped between two trap seals and the air-bound drain will block flow. I've seen, so if you go into a home and you have a double kitchen sink, and so you say you have an island. Okay, so older existing home, you have an island with a double sink, and sometimes they'll have two traps, like a trap underneath both sinks. Well, because they didn't really, plumbing code has come a long way, plumbing technology has come a long way, and so a lot of times back in the day, when you had both sinks trapped on one, like on one fixture on one island, uh, one one drain was intended to be an air vent, so that let me think about this. So yeah, one side of the sink was intended to be an air vent, and one side of the sink was intended to be the trapped part of the sink. Well, a homeowner came in or whatever, and they installed a garbage disposal, and so then they think, oh, normal plumbing practices, you got to trap, this side, and so then they trap both sides then, and now you have airlock. So because one or both sides was intended to allow air to get into the system because they didn't have an air admittance valve, or the drain line wasn't large enough to allow air to come in. Now you have a double trap sink, and so you have an airlock where if you fill both sides of the sink up with water, neither one is going to drain because there's no air there's no air being pulled into the system. So when you're evaluating sinks, look at that. I always fill both. Anytime I have an island with a double sink, I always fill both sinks or both sides of the sink up at the same time, and then drain to make sure that enough air is being introduced into the system to allow for proper draining. So, and then again, you'll have, it's very common to find S traps. This is an S trap. Here, very easy to siphon water out of there, and then you get the sewer gases. And then if you're on a septic system, you can get bugs or rodents coming up through the system. And bell traps, all of those other types of traps that I had mentioned before can all lead to easy clogging. So if there's anything but a normal P trap, I would recommend, just make a simple statement. Plumbing system is older. Recommend evaluation by a plumber. Upgrade as needed. Something simple like that. If you have, any of those older type of drain systems. And again, what I had mentioned before is that anytime, so, we all know that every plumbing appliance or every plumbing fixture has to have a drain trap. Well, sometimes those or has to have a P trap. Sometimes those P traps are in the slab, and but that's why you have those clean outs on the outside of the home to be able to clean access those P traps and clean them out, or let them flush or whatever needs to happen in order to get the drain to work right. Number 19, panel workspace. The workspace is needed to allow for safe clearance from any live components. It also provides enough room for free movement of a person who needs to examine, adjust, service, or maintain the electrical equipment. The space shall be at least 36 inches deep. The workspace should be at least 30 inches in width in front of the electrical equipment and not less than the width of the electrical equipment. If the panel board is wider than 30 inches, the workspace must extend its full width. The workspace should be clear of obstructions. The workspace's height from the floor or platform should be at least 6.5 feet. There must be access provided to the workspace at the panel. The workspace must not be designated for storage. Panel boards and overcurrent protection devices must not be located in closed closets, bathrooms, or over stairway steps. The workspace must have manually controlled artificial illumination installed. Clear space directly above and below. A space directly over a panel board that extends from the top of the panel board to the structural ceiling or to a height of 6 feet above the panel board, whichever is lower, should be provided. The space should be of equivalent width and depth of the electrical equipment. This dedicated space above the electrical equipment should be kept clear of components not related to the electrical equipment, such as plumbing pipe, HVAC ducts, etc. There should not be any interference with the direct run of cables and or conduits to the electrical equipment. A suspended ceiling with removable panels may encroach into this dedicated space above a panel board. According to the 2018 IRC, a dedicated space above and below the panel board equal to the depth and the width of the panel board must be maintained clear of all ducts, piping, and other foreign items to allow for maintenance, inspection, future work, and future installations. If you've been an inspector longer than a week, you've probably seen people use the space in front of an electrical panel as storage, specifically for cleaning supplies. It's very common. Or if in a garage, see all the time where storage, shelving and stuff is placed either directly in front of or in front of the operable door, but where you can't take off the panel cover. So obviously we want to call all those things out and make sure that, you have clear uninterrupted space to the electrical panel. Because homeowners don't understand the inherent dangers of an electrical panel. I am very good friends with the owner of the Arkansas College of Electricity, and even he, has had arc flash issues when he, before he went full time as an educator, he was in a residential electrical panel, and the panel just moved just right. He already had the panel cover off, and the panel moved just right, or a wire moved just right, or something happened, and he ended up having an arc flash. And the arc flash, and his way of explaining it, when you're in a panel, you're probably this close to the panel, and when you're evaluating it, looking at it, doing whatever you need to do, and if you have an arc flash, his explanation is all of a sudden, in a fraction of a second, you have a VW bug between you and that panel. The amount of force and the amount of energy that is created by an arc flash is very detrimental. And so if we are, as inspectors, going in and inspecting an electrical panel and it's covered and there's just stuff all the way around, and you're having to, the homeowner's moving and there's a bunch of boxes and stuff in there, and you move one box out of the way and you step over, and you go and you start working on the panel and you get an arc, God forbid you get an arc flash, and now and anybody who is going to be in that situation is going to try and take a step back or try and cover themselves or move quickly out of the way. And if there is anything around you, you have the potential for falling, damaging the homeowner items, hurting yourself. So I think I definitely take it for granted for sure, because I've done over 6,000 inspections. I've been in residential and commercial construction almost my whole life, and I still take it, and I take it for granted. Which generally that's why I like inspecting, or I like teaching new inspectors, is because when I'm in the field with them, I want to make sure that they are 100% safe, that they don't get injured on the job. And so it helps to remind me whenever I'm with them that I also have to take those same precautions. So, make sure that you have all the space needed. And if you're not comfortable inspecting, if things are in the way, you're not comfortable moving homeowner stuff out of the way to give you that working space, then you just state that in your report and you say not unsafe conditions. Recommend this to be moved. Now, you're probably going to get pushback from your buyer, from the seller. They're probably going to ask you to come back once all that stuff is moved. So you handle that however you want, and you always want to have, a good relationship with your client, with your realtors, with your referral partners, and all that stuff. So do what you need to do, but just make sure that you're safe and you're fully aware. You're not distracted. The one thing that you should never ever be distracted on. You should never be on your phone doing anything but paying full attention to that electrical panel. Because even, like I said, even the most experienced electrician can end up having an electrical issue, an arc flash, arcing, energized panels, any of that stuff. So just, make sure that you can keep working the next day. That's all right. Electrical service conductors. So we're going to start over here on the left. So that 3-foot clearance is based on close proximity of people to the service conductors. The clearance reduces the potential for damage to the service conductor and reduces the risk of accidental contact with the electrical conductors. Open electrical service conductors, like the one you see in the picture, and multi-conductor cables that are not installed in a raceway or provided with an approved overall outer jacket should have a clearance of at least 3 feet from the sides of doors, porches, decks, stairs, ladders, fire escapes, and balconies, and from the sides and bottoms of operable windows. These jackets on these service entrance conductors, they're UV rated, but weather and the sun, they take its toll. And you get, so say you have a teenager that's staying up in this room, they want to sneak out for the night. And so they open their window and they think that they can use this cable to help them lower onto the roof so that they can jump off the roof. Well, this cable has exposed wires, or the jacket is deteriorated, or or whatever. So you want to make sure that you have, you meet all the safe clearance distances for electrical wires, just to make sure that that one-off situation does not cause you or the homeowner or your client any issues in the future. Clearance from windows that can open applies only to the sides of the window and below the window opening. Service conductors and drip loops located above a window opening are considered to be out of reach. So, and I think we're going to go over this on the deck class next week. But, a lot of times decks are built after the fact, after the service, the electrical service has been installed. And so sometimes that deck is the only way to install that deck. Well, then you have, part of that contractor quote should include advising the client to have their electrical service moved. Because if that's the only place that the deck can go, then something else has to get moved. So so keep an eye on those things whenever you're doing your inspection, and make sure that items, systems, components that are installed after the original service has been installed still complies with the standards for the service. No clearance is required from windows that do not open. Electrical service conductors should have a vertical clearance of at least 8 feet above the roof surface. There are exceptions. The 8-foot vertical clearance above the roof surface should also be maintained for at least 3 feet horizontally from the edge of the roof, except when the service drop is attached to the side of the building. The 8-foot clearance may be reduced to 3 feet where the slope of the roof is 412 or greater, because there will likely be minimal travel across the roof with such a steep slope. The clearance may need to be increased more than 8 feet in height if the roof deck is expected to accommodate occupants, such as in the case of a rooftop court or a sun deck, or where the roof is also the upper deck of a parking garage. The service drop cables supported on and cabled together with a grounded bare messenger wire. The vertical clearance should be at least 10 feet from the electrical service entrance to the buildings at the lowest point of the drip loop of the building's electrical entrance, and above areas and sidewalks accessed only by pedestrians. Where there is no anticipated vehicle traffic, a 10-foot minimum vertical clearance is needed. Where vehicles are present, higher clearances are needed. The vertical clearance should be at least 12 foot above residential property, yards and grounds and driveways. The vertical clearance should be at least 18 feet above public streets, alleys, roads, and parking areas that are all subject to truck traffic. So trying to determine the height of a service drop can be difficult. There are methods. I mean, so not everybody does this. So it's up to you on how or if you want to call them out. So that being said, obviously, if the wire is hanging super low, a lot of times there's a reason for it. So, the most of the time, the electrical company is the one that runs the electrical service wire or the service entrance conductors. So they are going to comply, with their code. Now, I will say, homes that are very old, have had the service drop for a very long time. Codes and standards have changed a lot. So, the heights and the distances might be different. But if you get on a home that's been built within the last 20 years and you see that drop, and, if you were to jump and grab it, that's definitely too low. So, take a look at the mast or at the pole. A lot of times, sometimes, if you have a tornado or you have ice damage, and tree limbs fall on your service line, that can pull the masthead down, or in a really bad situation, or maybe if the pole is rotting, the electrical pole is rotting in the ground, sometimes that pole can start to drip, and then that causes the service drop to drop too. So definitely, if you don't have a method for determining how what the distance is from the ground to the electrical service conductor, then a lot of times you can only do your best guess. There are So for me, I have an extension pole that I use for roofs that I put my camera on, and I have on it the marked distances. And so, I stay a safe distance away. If I'm ever curious about the distance from the electrical service conductor, I will take that pole and, like I said, be a safe distance away, so that if the pole falls on the line or something like that, so that the pole can't fall on the line. But then you can use those extension poles and mark your distances on there to figure out how high that service drop is, or at its lowest point, how high it is. So there are methods that you can use to try to determine accurately what that is, instead of just eyeing it. You can also use, there's lots of things that you can use. You can use that the house is so tall at the peak, and so you can use the height of the house and the distance of, the siding and how deep the siding is, and then transfer that over to where the drop is, and then determine your drops that way. So there's lots of different methods that you can use. So digital laser, Richard Russell uses a digital laser. I love that one. That's a great one. hopefully there's no wind and blowing that service mast back and forth. But use the tools that you got, especially the ones that won't put you in contact with that service truck. All right. Next, particle board sheathing. Particle board is a generic term used to describe panels made of pieces of wood and particles combined with a synthetic resin and other binders bonded together under heat and pressure. The particle board panels should not be exposed to the weather. Particle board tends to absorb moisture and swelling can occur. It requires protection, and inspectors should check for weather protection. So a lot of times you're not going to see this stuff. I mean, really, the only time you're going to see the marking on these panel on the letter marks is on the underside of roof decking, on maybe on the interior walls that don't have drywall or insulation. That's that's really about it. Generally, your siding should all be okay. Sorry, I'm getting off track here. Lettermark. According to the 2018 IRC, particle board can be used to function as part of a wall system. It's often called particle board wall sheathing. There is an ANSI standard for particle board. A grade mark or certificate of inspection identifies the limitations under which the particle board may be used in residential construction. The grades will appear in the format of a letter followed by a hyphen and a number or another letter. If the panels are applied in a horizontal pattern across the wall, the end joints should be offset so that the 4 panel corners do not meet. The particle board wall sheathing should have a 1/16 inch gap between each adjoining panel board. That's to allow for expansion contraction. All edges of a panel should be supported. Fire blocking or equivalent framing members can be installed as intermediate edge supports. The inspector should check the bearing of the panel edges on the studs. At the studs, the panel edges should have equal bearing. The nails at the particle board panel should not be too close to the edge of the panel. The nailing should not be closer than 3/8 inch from any edge of the panel. Nails must be at least 3/8 inch from the edges for proper holding capacity. The nails should be spaced 6 inches on center at the edges and 12 inches on center at the intermediate supports. There are also alternate attachment methods that are acceptable. If the panel is a 1/2 inch thick and its grade is type M2, the maximum stud spacing is 16 inches on center when the siding is nailed to the studs and 16 inches when the siding is nailed to the sheet. We have another TPR, so we're going to go over this kind of quick because I think we're almost done here. So to prevent heating the water above 210 degrees, the temperature pressure relief valve must be installed in the hot water within the top 6 inches of the tank. Water heater tanks usually have an opening in the tank shell installed by the manufacturer. In order to properly sense the tank's water temperature, the temperature pressure relief valve must be located in the tank within the upper 6 inches of the hot water, where all the hottest water is located. The location is more important for temperature than for pressure, since the pressure is uniform through the tank. Water is essentially an incompressible solid. It has no latent heat energy within itself to expand when released, unless the water is superheated. Water hotter than 212 degrees is considered superheated water, and superheated water wants to change into steam at atmospheric pressure. It poses latent heat energy, which can flash into steam and create a force that is not unlike an explosion. Water would normally boil at 212 degrees, but inside a tank, it can't expand anymore, so it can't boil off into steam. Water in a closed system and under pressure, such as inside a hot water tank, has a much higher boiling point. For example, where water supplied to a tank is at 50 pounds per square inch, the boiling point is 297.7 degrees Fahrenheit. There is a tremendous amount of energy released as the superheated water is exposed to atmospheric pressure, and it immediately turns into steam. Every cubic inch of water becomes a foot of steam. Below is a chart, to the side over there on the left is a chart showing the explosive energy created in a 30-gallon hot water tank. water heater tank at various pressures and temperatures. This is why it is essential to avoid excessively high hot water or excessively high water temperature and pressure at water heater. So this kind of just goes over what we had already talked about in the previous slide, and this just gives you the exactly what we talked about the boiling point and the pounds per square inch, and that how much steam comes out. All right. FVIR stands for Flammable Vapor Ignition Resistance. In 2003, a new standard for water heaters was developed and phased in. It states the water heater should not ignite flammable vapors outside the water heater created by spillage of gasoline onto the floor. The Consumer Product Safety Commission found that thousands of fires, injuries, and deaths are related to water heaters. Most of these incidents were caused by improper storage or handling of spillage of gasoline. If the tank is in compliance with the FVIR standard, it does not have to be raised 18 inches in garages or similar locations unless required by the manufacturer or local code authorities. An FVIR water heater has the following components: a device to prevent ignited vapors from passing out of the combustion chamber, a one-way intake system to control the movement of makeup air into the combustion chamber, and an inner door and burner assembly to create a sealed junction with the combustion chamber, preventing combustion air and flammable vapors from entering the chamber through the front of the water heater. FVIR systems on Bradford White Defender water tank during normal operation. Air for combustion is drawn into the water heater through the openings in the jacket. This air travels down and around the combustion chamber and enters through the holes in the very bottom of the corrosion-resistant combustion chamber. The air then travels up through the oriented flame arrestor plate louvers, where the velocity of the air is increased and its direction altered. The air then mixes in a normal manner with the supplied gas and is efficiently combusted, producing very low nitrogen oxide emissions. In the case where trace amounts of flammable vapors are present in the air flowing into the chamber, the vapors are harmlessly ignited by the burner pilot flame. If the flammable vapors are present in sufficient quantity to prevent normal combustion, the burner pilot flame is shut down. Should the flammable vapors continue to burn, the flame arrestor plate prevents the flames from traveling backward and igniting vapors outside of the combustion chamber. The calibrated multi-purpose thermal switch recognizes this and shuts down the pilot and main burner. This switch also deactivates the burner and pilot in the unlikely event of restricted airflow caused by severe lint, dust, or oil accumulation on the arrestor plate. Yeah. Okay. Island fixture venting. The air admittance valve. Okay, so a cleanout should be installed for the island fixture vent pipes to provide access to routing, cleaning, and maintenance of all the vent pipes below the flood level rim of the fixtures. Air admittance valves are permitted on vent fixtures at island structures and in kitchens. Island vents should extend vertically above the drainage outlet of the fixture that is being vented before venting downward, vertically or horizontally. Island fixture venting should not be installed for a fixture other than a sink or a lavatory. Such a fixture is permitted with a dishwasher waste connection, a food waste grinder, or both. Air admittance valves are pressure-activated one-way mechanical vents. They are used when venting through the building's roof structure when venting through the building's roof structure is not available. This type of vent is common for kitchen sinks, especially when the fixture is installed in an island structure. When wastewater is discharged, the valve opens, releasing a vacuum, and the air is allowed to enter the vent for proper drainage. Waste outlets for sinks should be 1.5 inch minimum. The sink should have a strainer or crossbar to restrict the clear opening of the outlet. The drainage for the food waste grinder should be at least 1.5 inches. A dishwasher, food grinder, and kitchen sink can all discharge into the same 1.5 inch waste drain pipe. The branch water supply line for the dishwasher and kitchen sink should be at least a 1/2 inch pipe. The hot should be installed on the left and the cold on the right. The size of the P trap drainage should be at least 1.5 inches. The air admittance, okay. All right. When composite shingles are not securely attached, they can be damaged or torn away by high winds. When this happens, the interior of the structure becomes vulnerable to rainwater and infiltration. A waterproof underlayment should be installed beneath the shingles. When securely attached, it temporarily protects the building from rain if shingles are torn away by wind. All nails and staples used to attach roof sheeting must penetrate the underlying roof trusses. Otherwise, the sheeting will not be securely attached and can be easily torn away by high winds. If the building is in a hurricane-prone area, the following precautions are recommended. Shingles should be attached with nails instead of staples. The first course of shingles should be sealed to the starter strip with dabs or bands on the roof cement, roof cement. And if the building is within 3,000 feet of salt water, the nails should be hot dipped, galvanized, or stainless steel. Inadequate attachment of the roof sheathing resulting from poor workmanship is common cause of roof failures during hurricanes and other storms with high winds. All right, so these two pictures are what I was talking about. So when we were talking about maintaining the fire rated wall sheathing in a garage, this is kind of what I was talking about. They built the landing so this is a tankless water heater system. And they built the landing and then they drywalled down to it, but they left the gap open. So the fire rating of the drywall is not maintained in this situation. So this is the house side right here. So technically only this gap would really have to be sealed or filled. If there were a 2x4 going on the back of this that they secured to, then that would not be required. But this is a void. There's a stud here, there's stud here, stud here. So this gap is free and open to the interior wall. And then this is kind of the same thing. This is the upper portion of that water heater where they did not seal the ceiling penetrations, which is voided, which has compromised the fire rating of the ceiling going into the attic. And then here is the code check diagram. So I love code check. I use it a lot. So this shows you how the underlayment should be layered over the drip edge and under the rake end. So again, if water gets below, if water gets below the shingles, it's going to ride that underlayment all the way down and then should come off the drip edge and then into the gutter. But what is happening is that they are putting the underlayment down first and then putting the drip edge on top. And so when water rides down, it gets in between that junction between the top of that drip edge there and the underlayment, and then it starts to rot the roof decking up here, and then it starts to run up. And then the rake end, again, so rake end is to kind of hold the underlayment down, but when it gets down to the fascia or the edge of the roof, it has to be over the drip edge. Where are we at on time? I think we're right about, yep. We got about 8 minutes. Rick did state, so so these gaps, a lot of times what the fix is now is that they come in with, instead of, drywalling and mudding and all this stuff, they just come in with fire rated foam, and then they bring this in. Now, I will tell you, there is a lot of controversy going on with fire rated foam right now. So there is a lot of fire rated foam on the market, but there is only very specific fire rated foam that actually meets fire rating standards for this application. So again, we're not really going to know, especially if we come in after the fact and we see fire foam, I'm happy with that. But when you're talking about technicalities, technically there is only a handful of acceptable fire rated foams that are out there. There's a lot of foam out there that they just color orange just to make it look like fire rated foam. So like I said, there's all different types of materials and components that are out there now that they color for, whatever reason. And so sometimes they color it orange just to color it orange, and it doesn't actually have any fire rating capabilities. What I like to see, before I did this job, I came from commercial construction. And so that dark red fire paste is what I'm used to seeing. That's the stuff that I would prefer to see, but it's very hard. You'll almost never see that in residential construction. Any other questions, concerned? All right. Well, I hope to see you guys all next week for the deck inspection. the deck class. It's going to be awesome. I love, I very rarely have I found a deck that was installed or that was, installed correctly. So we have a lot of great examples, a lot to talk about, and we might have to burn through that one a little faster instead of talking so much because there is a lot more content in that class than there is in this class. So I appreciate everybody being here. It's a blast. I love doing this stuff, and I hope to see you again in the future.